Assalamualaikum and good day everyone. We are from AS1205B. Today we are presenting our experiment 5, which is gas chromatography. Before we start, I will introduce our group members. We have Muhammad Ifan Najwan, Noor Atira Hanim, Noor Jawahi, Noor Kristina Batrisha and also Sharifah Sofia Anissa. In this presentation, we will discuss about the objective of the experiment, introduction, apparatus and chemical, procedure, result, discussion, conclusion and question, and last but not least our references and appendix. Let's start with objective. In this experiment, we have 4 objectives. The first one is to determine the retention times TR of N-butanol and 2-propanol. The second one, to identify the component present in standard mixture based on the TR. Next, to identify the component present in unknown sample. Last but not least, to determine the effect of temperature on TR and RS. This experiment used gas chromatography to separate different volatile compounds. Gas chromatography separates compounds based on how easily they evaporate and how strongly they interact with the stationary phase inside the column. One important result in gas chromatography is the retention time, or we call as TR. This is the time that compound take to travel through the column. Different compounds have different retention time. We also can use them to identify the compound. In this experiment, we also study how column temperature affect retention time and resolution. Changing the temperature can change how quickly compound move through the column and how well they can separate it. Finally, N-butanol and 2-propanol are used as standard compound to compare and identify the result. Move on to apparatus and chemical. In this experiment, the apparatus that we use is syringe, beaker and dropper, while chemical that we use is 2-propanol and butanol, a standard mixture of 2-propanol and N-butanol, and also unknown sample.
Hello everyone, my name is Muhammad Ifan Najwan bin Shamsuri, and here we have a diagram of gas chromatography. So first is the carrier gas. It usually contains an inert gas such as nitrogen, helium and hydrogen, and this gas will act as the mobile phase, transporting the vaporous sample through the analytical column. Then we have this flow controller, which regulates the flow and pressure of the carrier and the sample. After that, the injection port, which is the heater inlet where samples are introduced and instantly vaporized. Moving on with the column, which is coated with a stationary phase that interacts with the analytes to different degrees. And then the detector, which measures the components exiting a gas chromatography column, converting separated compounds into electronic signals. Finally, the recorder, which is the system used to capture, process, display the electrical signals generated by the detector. Now we move on to the flowchart of using a gas chromatograph. So the sample is first introduced into the gas chromatograph with a syringe, or in some models using an autosampler. The sample is injected into the injection port, which enables the injection of the sample mixture without losing the mobile phase. Connected to the injection port is the analytical column, which is a long, narrow fused silica or metal tube which contains the stationary phase coated on the inside walls. The analytical column is then held in the oven, which is heated during the analysis to elute the compounds of different boiling points. The outlet of the column is inserted into the detector, which responds to the chemical compounds eluting from the column to produce a signal. Then this signal is recorded by the acquisition software on the computer to produce a chromatogram. If needed, some software can quantitate or produce an amount of that compound referencing a known amount of that compound.
I will explain the data and result obtained from the gas chromatography analysis. At 70 degrees Celsius, the standard mixture produced two peaks with retention times of 2.67 minutes and 5.81 minutes. The 2-propanol sample had a retention time of 2.7 minutes, while the N-butanol had a retention time of 5.95 minutes. The unknown sample showed a retention time of 5.96 minutes, which is very close to the retention time of the N-butanol. Therefore, we identified the unknown sample as the N-butanol. The standard mixture was then analyzed at higher temperature of 100 degrees Celsius and 140 degrees Celsius. As shown in the table, the retention times became shorter as the column temperature increased. The chromatograms on the next slide can be referred to as the visual representation of the results shown in this table. They clearly show the peaks and retention time for each sample, supporting the identification of the unknown sample as N-butanol as explained in this table.
Now let's go to the discussion of this experiment. For the first objective, the retention time of 2-propanol was determined to be 2.708 minutes, while N-butanol showed a retention time of 5.957 minutes. Since 2-propanol has a lower boiling point and higher volatility than N-butanol, it traveled through the GC column more quickly and erupted first. According to Bizo et al. 2023, retention time is a characteristic property of a compound under fixed chromatographic conditions, although it can be affected by operating parameters. Moving to the second objective, the standard mixture produced two peaks at 2.677 and 5.817 minutes. These values closely match the retention times of the pure standards. Therefore, the peaks were successfully identified as 2-propanol and N-butanol. This demonstrates that comparing retention times with authentic standard is an effective method for qualitative identification under the same chromatographic conditions. Third objective, the unknown sample produced a retention time of 5.963 minutes, which is almost identical to retention time of pure N-butanol at 5.957 minutes. Therefore, the unknown sample was identified as N-butanol. Although retention time alone cannot always uniquely identify a compound, comparison with authentic standard analyzed under the same condition provide valuable qualitative identification for this experiment, as discussed by Bizo et al. 2023. For the final objective, the effect of column temperature on retention time and resolution was investigated. At 70 degrees Celsius, the compounds eluted at 2.677 and 5.817 minutes. When the temperature increased to 100 degrees Celsius, the retention time decreased to 2.274 and 3.28 minutes. At 140 degrees Celsius, the retention times further decreased to 1.958 and 2.24 minutes. This shows that increasing the column temperature reduced the retention time because the compounds become more volatile and travel through the column more quickly. This observation is consistent with the finding reported by Kim et al. 2026, who explained that higher temperature increased volatility of volatile organic compound. However, as the temperature increased, the two peaks become closer together. This indicates a decrease in chromatographic resolution, meaning the separation between the compounds become less effective. Therefore, although higher temperature reduces the analysis time, an appropriate column temperature is still required to achieve good separation and accurate identification. Now, let's go to the conclusion.
In conclusion, all the objectives of this experiment were successfully achieved. We determined the retention times of 2-propanol and N-butanol, identified the components in both the standard mixture and also the unknown sample by comparing the retention times, and also investigated the effect of oven temperature on chromatographic separation. We found that increasing the oven temperature decreased the retention time but also reduced the chromatographic resolution. All in all, this experiment demonstrated that gas chromatography is an effective technique for separating and identifying volatile compounds based on their retention times. For future work, optimizing the oven temperature and other operating conditions could further improve the efficiency and resolution of compound separation. That's all from us. Thank you.